Alrighty, folks. So on the bell work, it says that the figure on the left above shows a wheel with a mark on its rim. Okay, and the wheel is rotating this way. The wheel is rolling on the ground at a constant rate along a level straight path from a starting point to an ending point. The graph y equals d of t on the right could represent which of the following as a function of time from when the wheel began to roll. So first thing we want to do is we want to pick out the important information from this paragraph. Okay, so we have a rolling wheel, it's at a constant rate, and it's a level straight path. Okay, and it has a start and an end point. And this is the starting point, ending point is it's continuous. So if we look at our answer options, first one is A, it says the speed at which the wheel is rolling. So if we're looking at our graph here, you can see it has high points, low points, high points, low points. This contradicts what was given in the question. It said that it rolled at a constant rate. So if we have a constant speed on a level straight path, that means that we should have a flat line, okay, because the speed is constant. B, the distance the wheel from its starting point. So here, once again, if we're approaching this as distance, so that means we're starting when we're way far away, and then we're going back, and then we're back to the starting point, back. So you see how it's kind of fluctuates. That would indicate the wheel's going this way, and then coming back this way, and then going back this way. That's, once again, it's kind of, it's contradictory to what the paragraph said, because it's at a constant rate along a level straight path. Okay, so it can't be answer B. Answer C, the distance of the mark on the rim from the center of the wheel. So if we're looking at our diagram here, our marks here, our center is. So with this wheel rolling, is that going to affect the radius? Well, no, because the radius of the circle or the wheel is constant, right? It's going to be the same over and over and over again. It's never going to change. It doesn't matter if you lay it on its side or whatever you want. It's still going to have the same radius. So answer choice D, the distance of the mark on the rim from the ground. Okay, so we're starting at a high point here. You can see that's representative. And as we roll, our mark is going to touch the ground. It's right there. Then it's going to go back after it completes its first revolution. And then it's going to touch the ground again, and then it'll go back. So from the information in our paragraph, process of elimination, we can conclude that the answer choice is D, or the correct answer is D. Before we get started on lecture, hopefully you guys heard Miss Sahlberg's announcement today. We have all the calculators. The high school office has all of the slips to check it out and stuff. So you guys are going to want to start checking those out. Hopefully you can get them by Monday, by next Monday, the 29th, because we're going to be utilizing them. We're going to spend a whole week on just calculator functions. That way we can get better and get used to them. Then you'll be able to use them for your homework. In turn, we'll be able to use them for the SAT. So we really want to get those checked out. Hopefully you can get them by Monday. And you can reach out to the front office to check it out. All righty. Off to lecture. Okay, so previously we've identified and manipulated graphs of functions.
Yeah, when you're lecturing, so
You'll listen to everyone go over the warm-up?
I just said that now that you're lecturing.
You were on your phone from the beginning of class, Nick. I can see you on your phone.
I was reading the lecture. No, you would know.
Thanks, Brock. Thanks, Zuleika. Sorry about that. I had to pause it because I had to talk to somebody, but we're okay. So what I was saying is the quadratic function is broken down into these three parts. You'll see it generally with three terms. You have ax squared plus bx plus c. The a value is your vertical expansion factor. Okay, it's what expands your graph up and down. Okay, or it'll compress it and expand it horizontally. Bx is your what's known as the linear factor. Okay, that's what moves your graph left to right. And then C is your constant, which moves your graph up and down. Okay, so those are how those three terms interact with each other. Another thing to pay attention to is if we end up in a situation where we have a negative a value, that is going to flip your graph over the x-axis. Okay, and these graphs, they all come out to the shape of a parabola. Parabolas, you're probably a little bit familiar with them. They are the U's. Okay, so your quadratic term is ax squared. And once again, A expands your graph or compresses your graph. If it's negative, it's what flips your graph over the x-axis. Your linear term is the bx, so it moves your graph left and right. The constant term is what moves your graph up and down. Okay, it's also what will turn into being your y-intercept. Parabola is the graph shape. Okay, it looks like a horseshoe, and it has a very point at the minimum, or it has a minimum or a maximum. Then your axis of symmetry. Okay, for your vertex and your axis of symmetry, those are probably the two most important things. So if I just draw a brief parabola like this, like I said, it's that U shape. This point at the very bottom and in the middle is what's known as your vertex. Okay, the x value of your vertex is what's known as the axis of symmetry. That's because each parabola has line symmetry, meaning that if we were to fold it in half, they would map onto each other. It would map onto itself. Okay, so when you're graphing these things, the vertex and the axis of symmetry are the most crucial points. Okay, your vertex will also turn into your max or minimum value. The axis of symmetry, if you use it right and use it strategically, it makes graphing these things pretty simple, pretty easy. And that'll be the first thing that we calculate each and every time that we have, or each and every time that we're given a parabola to graph. The final term is the vertex. Once again, that's your point. It's the midpoint of the parabola. You have the maximum value, which is, as it sounds, it's the highest y value that it'll hit. And then you have minimum value. Okay? So for a maximum or a minimum, you can determine whether you have a maximum or a minimum by the sign of A. Okay? If you have a positive A value, that means that you have a minimum. Okay? And our graph is going to open up like that. If you have a negative A, that means that you're going to have a maximum, which makes your parabola open up like that. So you can see the y value of the vertex will turn into either the minimum value or the maximum value based upon the sign of A. So if it's positive, your parabola is opening up. If it's negative, your parabola is opening down. And that's all from the value of A, in addition to stretching it and compressing it. All righty, let's get into some problems. Or here's your key concept. Okay, so there it kind of puts all of it together. So you can see, consider the graph y is equal to ax squared plus bx plus c, where a cannot equal 0. The y-intercept is always your c value. Okay, that's because when you plug in a 0, you square it, you get 0 multiplied by 0 plus something else that's multiplied by 0. You're going to be left with the constant. Okay, the second portion of this, the equation of the axis of symmetry, is x is equal to a negative b over 2a. Okay, x is equal to a negative b over 2a. We pull that straight from our formula. So you can see the coefficient b, that's going to be our numerator. Coefficient a, we're going to multiply it, and we're going to put it as the denominator. This will be the location of the x value of the vertex as well. So that's why this point right here is very crucial. Okay, it's very crucial to do this. Okay, and really, realistically, you can graph these within 3 points. I typically use 5 points because it's very simple, very easy, especially when I'm using the axis of symmetry. Okay, and the axis of symmetry, again, that's where the graph can fold upon itself. Okay, it's a useful thing to know that because really it cuts your workload in half. We really only have to find two more x values after the vertex, and then we can map them across. Give you a second to get that stuff down. All right, let's get into the first problem. So we're going to graph f of x, which is equal to x squared plus 3x minus 1 by making a table of values. Okay, table of values graphs, they are both the same thing. So we have x squared plus 3x minus 1. Okay, the first step to graphing these is find the location of the x value of the vertex and your axis of symmetry. So you're going to run it through negative b over 2a. So x is equal to a negative 3 over 2 times 1. Okay, my value of a is 1. My value of b is 3. So you can see that this comes out to a negative 3/2 or negative 1.5. Okay, this is a key point. I'm going to start to build my table with negative 1.5 is the center of my graph, right? That's going to be my definite center, okay? So when I'm selecting x values, I want to be close to where the center of my graph is. It wouldn't make sense for me to choose an x value of 10 to plug in because that's 11.5 units away from where my graph is going to start, since it all starts at the vertex. Okay? Once you have this, the next thing you want to do is you want to plug it in so that we get our maximum or minimum value. Okay, or our y value. So if I plug in negative 1.5 quantity squared plus 3 times quantity of negative 1.5 minus 1, 1.5 squared, I've believe is 2.25 plus a negative 4.5 minus 1. Let me double check to make sure that I'm right on my square. Yep, 2.25. Okay, so then I can begin to just solve it. So 2.25 plus a negative 4.5, that's going to give me a negative 2.25 minus 1 gives me a negative 3.25. Yep, perfect. Okay, so this is the location of my vertex. Okay, I ran it through to get my x value, and then I plugged that x value into the equation to get my y value. Okay, same stuff that you've done previously. Now, to select your other points, like I said, you want to be strategic. We want to be around our vertex x value, so then we can just makes our life very easy and want to choose simple points. So I'm going to choose -3, -2, -1, and 0 as my other points. Okay, and the reason being, they're all equal distant from the vertex. Like -2 and -1 is a half a unit away from a -1.5. Okay, -3 and 0 are 1.5 units away from 1.5. That's useful to me because I know that the graph has to map onto itself from the axis of symmetry. So this is where I was talking about how we can eliminate some of the work. And looking at these, -1 and 0 are much easier points to plug into this rather than -2 and -3. Okay, so I'm going to plug in -1 first. So -1 squared plus 3 times -1 minus 1. -1 squared is 1. 3 times a -1 is -3. Minus 1. 1 minus 3 is -2. Minus 3. 1 minus 3 is -2. Minus 1 is a -3. Okay? And then 0. 0 will also be the location of my y-intercept. From the key concept that I just had up, and you can see that I want to plug it in 0, my y value is going to be -1. Okay, that's because 0 squared is 0, plus 3 times 0, which is 0, minus 1. So 0 plus 0 minus 1 gives me a -1. Now, the beautiful thing of knowing that these are equal distant, because from the vertex, they're both half units, I can transform these numbers up for these. It's -3 and -1. Okay, that's the joy of the axis of symmetry, because the only way that they would fold on top of each other is if my x values are equal distant away from the vertex, and then the y values are going to be the same. So that's why -2 and -1 are both y values of -3. -3 is -1, 0 is -1. Okay, and you could actually check that if you wanted to. Like if you plugged in -3, -3 squared is 9, plus 3 times -3, which is -9, minus 1. So 9 minus 9 is 0, minus 1 gives me 1. Okay, so if you think about this strategically, it makes your life a whole lot simpler and easy. Okay, because you can divide your workload in half rather than having to plug in 5 total points. So choose integer values for x, evaluate the function. That's after we find the vertex. We always want to find the vertex first. So here's the x values they chose. -3, you can see it's -1. -2 is -3. -1 is -3. 0 is -1. 1 is 3. And our vertex would fall right in between there. Okay, at -1.5, -3.25. And then to graph it, we just plot these points and then connect them with a smooth curve. So our vertex would be here. Here's -1, here's 0, here's 1 for our y values, -2, -3. Okay, so if we approach it strategically, it's not the most difficult thing in the world. So which graph is the graph of f of x, which is equal to 2x squared minus or plus 3x plus 2? Okay, so the way that I want to do this to make my life simple is first, I want to see if I can eliminate some answers. Okay, and the way that I'm going to eliminate answers is based upon the sign of my a value. Remember, if a is positive, my parabola is opening up. If a is negative, my parabola is opening down. So since these are opening down and I have an a value that's positive, I know it can't be a or d. Okay, so those two answers are automatically eliminated. Okay, the next thing that I want to do is I want to find where my y-intercept would be. Okay, remember the y-intercept is always the constant value of c at the end. So if I were to plug a 0 into this, I would be left with 2. Well, which graph has a y-intercept of 0, 2? And that is answer C, right there. So with a multiple choice question, I can do it pretty simply without even like really doing much work, just by analyzing my equation. Okay, so consider the quadratic function f of x, which is equal to 2 minus 4x plus x squared. Find the y-intercept, the equation of the axis of symmetry, and the x-coordinate of the vertex. So first thing I want to do is I want to rework this so that it's in the form ax squared bx c. Right? That way it's just visually simpler to me. I mean, we can do all of the processes that we would need to do, but this way, if we just get in the habit of writing it in standard form, it just makes your life easy. So we're dealing with x squared, and that is going to be a minus 4x plus 2. So axis of symmetry and the x value of the vertex, those are at the same location, and they are found by running it through x is equal to a negative b over 2a. So in this case, x is equal to a negative 4 over 2 times 1. Because my a value is 1, my b value is negative 4. So these two negatives are going to cancel out, and I'm going to be left with a positive 2. Okay, because 2 times 1 is 2. Negative 4 over 2 is negative 2. The second negative cancels out. In this case, sometimes on this equation, one of the hard parts is finding out if it's positive or negative. If you count your negatives, how many instances there is a negative sign. If it's odd, that means you're going to have a negative x value. If it's even, you're going to have a positive x value. So since this case I had 2, if that's even, I know my x value is positive. So the axis of symmetry and the x value of the vertex is 2. Okay, for the y-intercept. That is what the question is asking us. Y-intercept occurs when we plug in 0 into this equation. So 0 squared minus 4 times 0 plus 2. 0 squared is 0. 4 times 0 is 0. So 0 minus 0 is 0. Plus 2, my y-intercept is 2. The x-coordinate of the vertex. So we've done all that. The last thing that I'm going to do is just find the value of my y value of the vertex. Should have done that before I did the y-intercept. That's okay. Just by plugging in the x value of the vertex into the equation. So 2 squared minus 4 times 2 plus 2. So 2 squared is 4 minus 8 plus 2. 4 minus 8 is a negative 4, plus 2 is a negative 2. So the location of my vertex is 2, negative 2. That will also be my minimum value because my A value is positive, so my graph is opening up. My axis of symmetry is on the X value of 2. The Y-intercept is at 0, 2. I think the internet's slow today. It's okay. I'm going to post the lecture. So they rearrange them, like we said. Y-intercept is always the constant, C. Use A and B to find the equation of the axis of symmetry. So X is equal to a negative B over 2A. We plug in our functions. You can see that the X value is going to be 2. And then to find the Y value of the vertex, we have to plug that back in. Okay, so in this situation, since we had a positive A value, I know I'm going to have a minimum value, and that value is the Y value of the vertex. Okay, so the Y value of the vertex is the minimum or maximum. So we got another one, or it's the same equation, but it's okay. It never hurts to see me do it again. So rework it to get it to x squared minus 4x plus 2. Okay, once again, we're going to run it through the equation for the vertex, negative b over 2a, because that's the most important point. So x is equal to a negative 4 over 2 times 1, which is equal to 2. Start to build my table from there. Okay, now I want to find the y value of my vertex by plugging 2 into my equation. So 2 squared minus 4 times 2 plus 2, that's 4 minus 8 plus 2 is equal to negative 2. Right there. So now I can work by plugging 0, 1, 3, and 4. Okay, like I said, in addition to finding the vertex, you want to be strategic about selecting points. You want to select points that are equidistant from your axis of symmetry. That way you only have to do one side and you can bring those answers down. Okay, so the easy side to do is 0, 1 here. So 0 squared minus 4 times 0 plus 2 is going to give me 2. My y-intercept, okay, that's 2 units away from my axis of symmetry, which is the same as 4. So those y values are going to be the same. Now the next one to plug in is either 3 or 1. So 1 is obviously easier to plug in than 3. So 1 squared is 1. Minus 4 times 1 is minus 4, plus 2. 1 minus 4 is a negative 1. 1 minus 4 is a negative 3, plus 2 is a negative 1. And there I've completed building my table. Now if I want to plot my points, draw my x and y axis. So 0, 2, 4, 2, 1, negative 1, 3, negative 1, 2, negative 2. Just like that. That's just the graph representation of that table. So choose values of x that are less than 2 and some that are greater than 2. That's because that's where our vertex is. And you can see our y values. So 0 is 2, 1 is -1, 2 is -2, 3 is -1, 4 is 2. Okay, it's the same function. So that's just the steps to graph it, which we've already built the table for. So you can see that's what their graph looks like. Okay, consider the quadratic function f of x, which is equal to 3 minus 6x plus x squared. Find the y-intercept, the equation of the axis of symmetry, and the x-coordinate of the vertex. So, once again, they want you to rewrite it. So first step is change it into ax squared plus bx plus c and get it into that form. So it was 3 minus 6x plus x squared. So that turns into x squared minus 6x plus 3. Okay, so axis of symmetry and the x value of the vertex. Run it through x is equal to a negative b over 2a. So in this case, x is equal to a negative -6 over 2 times 1. I have an even amount of negatives, so that's going to be positive -6. That turns into 3. Okay, so the x value of the vertex is 3. That is also the location of your axis of symmetry. And then they want us to find the y-intercept. The y-intercept is the easy one because it's always the constant. If I were to plug in 0, it'd be 0 squared minus 6 times 0 plus 3. So my y-intercept is equal to 3. So looking at our answer choices, looks like it should be answer C. Okay, consider the quadratic function. So it's the same one that we just had. So it includes the vertex. So we knew our vertex was at 3. So what we're going to do is build our table. So I know my x value of the vertex was 3. Make that a little better. 0, 1, 2, 4, 5, 6. I'll even make more points this time. I don't know why. Oh, so I can encompass 0. Okay, first step, find the y value of the vertex by plugging in your x value that you just found. So in this case, it was 3. So when I plug that into the equation, I'm left with 3 squared minus 6 times 3 plus 3. 3 squared is 9. 6 times 3 is 18 plus 3. So 9 minus 18 is -9 plus 3 is equal to a -6. Okay, that's the location of my vertex. In this case, that would also be the minimum value because my parabola is opening up. Okay, so all the other points are higher than -6. Easy point to find is the y-intercept. Okay, so when I plug in 0 into this equation, it's going to be left with the constant, so 0, 3. So my vertex is at 3. 0 is 3 units away. 3 units away from 3 in the other direction is 6. So I know it's going to be at 6, 3. Okay, and then to fill out the rest of my table, I want to choose the easier points. I'm going to choose 1 and 2 because those are the simple ones to handle. So when I plug in 1, I get 1 squared minus 6 times 1 plus 3. 1 squared is 1 minus 6 plus 3. 1 minus 6 is a negative 5 plus 2, or plus 3 is a negative 2. Just like that. And if I plug in 2 into my equation, it's 2 squared minus 6 times 2 plus 3. 2 squared is 4. 6 times 2 is 12 plus 3. 4 minus 12 is 8. Yep, 4 minus 12 is 8 plus 3, or 4 minus 12 is a negative 8 plus 3 is a negative 5. So if we take that information, select our answer choices. 1, negative 2, 2, negative 5, 3, negative 6, 4, 5, negative 2. Looks like it's going to be answer D. Just a little bit. There we go. Cleared it up a little bit. Okay, so once again, we would want to rewrite this. So it would be x squared minus 6x plus 3. Okay, so x squared, that's a positive a value, which means I can eliminate answer choice B. That's the same equation. So 3, negative 6. That's 1, 2, 3, 4, 5, 6. Bang, 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 bang. Looks like it's going to be answer choice A here. And that's just them wanting you to select the graph of the table we just made. Okay. So graph of f of x, which is equal to ax squared plus bx plus c, where a cannot equal to 0. It'll open up and has a minimum value if a is greater than 0. So if a is positive. It opens down and has a maximum value if a is less than 0 or a is negative. Okay, and the y-coordinate of your vertex is the maximum or the minimum value. Okay, it's the y-coordinate. That's the part that we're focused on. Okay, so consider f of x, which is equal to a negative x squared plus 2x plus 3. Determine whether a function has a maximum or a minimum value. So the only thing I have to ask myself is if it has a maximum or minimum is what is the sign of a. In this case, a is negative, so that means that I have a maximum value. My parabola is going to be opening up down. So since a is negative, the graph opens down and the function has a maximum value. Okay, so the function negative x squared plus 2x plus 3, state the maximum or minimum value of the function. So this is a different question than what they just gave us. Okay, this, it says determine whether the function has a maximum or minimum. This one, they actually want us to state the maximum or minimum value. So the only thing that we have to do here is we have to find where our vertex is. Okay, we already know that because it's a negative a, we have a maximum value. Okay, to find the location of my x value of the vertex, I run it through x is equal to a negative b over 2a. So in this case, our equation was negative x squared plus 2x plus 3. So when I plug those in, if x is equal to negative 2 over 2 times negative 1. So that's a negative, or that is going to simplify to a positive 1. Because 2 times negative 1 is negative 2. Has a second negative, they're even. So my x value of the vertex is 1. It's also the location of my axis of symmetry. To find the y value, I take what I just found and I plugged it in to my equation. So here I have a negative 1 squared. Okay, and the key is that the negative's on the outside. So we have to take the exponent first and then apply the negative. Okay, so order of operations. So it's negative 1 squared plus 2 times 1 plus 3. 1 squared is 1. I'm going to assign a negative to it is negative 1. 2 times 1 is 2. And my constant of 3. So negative 1 plus 2 is 1 plus 4, or plus 3 is 4. Okay, so 4 is the maximum value. Okay, there won't be a y value higher than that. So we plug it all in. The maximum value of the function is 4. Okay, same equation. So consider f of x, which is equal to x squared plus 2x plus 3, and state the domain and range of this function. Okay, for all of your parabolas, the domain is very easy. Okay, because there's not any x values that we could plug in that makes this undefined. Okay, it's constant, it doesn't ever end. So your domain for all of the parabolas is all real numbers. Okay, the range is limited based upon if you have a maximum or minimum. So in this case, we had a maximum value of 4. So that means that all of my other y values must be less than or equal to 4. Okay, your range is the only thing that gets cut off when you're talking about polynomials. Okay, consider the function x squared plus 4x minus 1. Determine whether the function has a maximum or minimum value. So we have a positive a value, so we know that we have a minimum. Because our parabola is opening up. Okay, consider the function x squared plus 4x minus 1. What is the maximum or minimum value of the function? So we run it in. We run it through. X is equal to a negative 2b. Negative x is equal to a negative b over 2a. So I have x squared plus 4x minus 1. If I plug that in, negative 4 over 2 times 1, I get a negative 2. I'm still sharing my screen, so you can't even see what I'm writing down. Okay, so once again, define the x value of the vertex first. It's the location of the axis of symmetry. It's the most critical point of the graph. You plug it into a negative b over 2a, you get a negative 2. Then you plug negative 2 in to get your maximum or minimum value. So negative 2 squared plus 4 times negative 2 minus 1. Negative 2 squared is 4. 4 times negative 2 is a negative 8. minus 1. 4 minus 8 is a negative 4. Minus 1 gives me a negative 5. So my vertex is at negative 2, negative 5, making my minimum value negative 5. Okay, we have the same equation. So what are the domain and the range of the function? Remember, domain is never limited for a parabola or a quadratic. So that's always going to be all real numbers. We have a minimum value. So all of our y values need to be greater than or equal to a negative 5. So our answer is A. Okay, quadratic equations in the first world, in the real world. Souvenir shop sells 200 coffee mugs each month for $6 each. The shop owner estimates that for each 50-cent increase in the price, he will sell about 10 fewer coffee mugs. So per month, how much should the owner charge for each mug in order to maximize the monthly income for the sales? So the first thing we want to do is we have to write an equation for this. Okay, and we want to consider what we have. We have it's $6 for each mug. I can walk you through the slides. Or first, for a few key things that we have. So income is equals number of mugs times the price. So for $6, if they're selling 200, 6 times 200 would give you 1,200. Okay, we're going to set that to the variable. Let X equal the number of 50-cent price increases. Let L in I of X equal the income as a function of X. So they're just breaking it down where X is 50. So the number of mugs, so that's 10 times for every 50-cent increase, and then the price per mug. So in this case, we're going to FOIL this out. Then we'll simplify to get 5x squared plus 40x plus 1,200. Okay, so here's the equation that we're dealing with. Negative 5x squared plus 40x plus 1,200. Written in ax squared plus bx plus c form. Okay, so we know we have a maximum value and he wants to maximize his income. And this is the equation and maximize it. So what we're going to do is we're going to find the x value of the vertex. We're going to plug that in so that we can get our maximum value. So once we plug it into x is equal to a negative b over 2a, we get our axis of symmetry and the x value of our vertex, which is 4. Okay, and then we plug 4 into that equation. And we get that it should be $8. We don't have any word problems today. All righty. So I want to get you guys